You know, the real numbers come in all sorts of shapes and sizes, and actually, they can be classified into different types of numbers. We have integers and whole numbers and natural numbers and even irrational numbers. So let's take these numbers and take a look and see, well, what are they? So here's a list, and we have columns for the real numbers, the rational numbers. Those are the ones that can be expressed as a whole number divided by a whole number, or as a decimal that either terminates or is repeating. Integers, those are the numbers that are 1, 2, 3, 0, and also the negatives, -5, -16. The whole numbers, those are the numbers that start 0 and then go 1, 2, 3, 4, and so on. The natural numbers that start at 1, 1, 2, 3, 4, and so on. And the irrational ones, these are the sort of the mysterious ones. They're the leftover numbers, the numbers that don't fit into any of these other categories right here. So let's try and see if we can actually check off all that apply for each of these numbers. So let's start with the second one. I'm going to leave the first one for last. So 0.3, now that bar, remember, means that it's 0.3333 repeating forever. It's a real number. And since it repeats forever, this decimal expansion, it's a rational number. But it's not an integer because there's this decimal part to the right of the decimal point. So it's not an integer, and therefore it's not a whole number, it's not a natural number, and since it's rational, therefore it's not irrational. So 0.3 with a bar is a real rational number. What about 0.945? Well, that decimal expansion terminates. It's a real number, and since the decimal expansion terminates, it's a rational number, not an integer, whole number, natural number, or rational. 0. 0 is a real number. It's a rational number because I can write it as 0 divided by 1. And is it an integer? It sure is. Is it a whole number? Yeah, it's the first whole number. But it doesn't make the cut to be a natural number because the natural numbers start at 1. So no dice there, and it's not irrational since we already know it's rational. -5/4, what do we have here? It's a real number. It's a rational because it's the quotient of two numbers. It's not an integer, not a whole number, not a natural number, not an irrational number. And that leaves us to the very last one. You've been waiting for this, square root of 3. Why did I save that for last? It's a real number. And it turns out that that's all we can say for sure right now. But I'll tell you the secret. I happen to know, because I know a lot of mathematics, that it turns out it is not a rational number. This is an example of a number that's none of these, which forces it to be an irrational number. But why that is true is by no means obvious, and we shouldn't understand or know it. But I'll just tell you that as a little teeny fact you can keep under your hat. The square root of 3 is an example of an irrational number. Neat. Numbers come in all shapes and sizes.